Beyond Science, Conversations with Arthur M. Young. Interviewer Charles Fauvre discusses issues of science and consciousness with Arthur Young, honored inventor of the Bell helicopter, philosopher, and author of The Reflexive Universe. Today, is the universe objective? A look at the scientists' involvement in the world they study.
Hello. Arthur, one of the premises basic to modern science is that the world is somehow out there, that is objective to us. Do you care to cast doubt on that premise?
As long as it doesn't prevent saying there's a larger sense of cosmology which involves what is not objective. In other words, it has to be objective to something. That's one way to put it. But the old Chinese thing, can space extend only to the east?
I'm not familiar with that.
Well, that's the way. That's it.
All right.
Can space extend only to the east? Can the world be solely objective?
I see. All right. I guess it really serves the scientist pretty well to act as though the world were objective, does it not?
Well, I think we have to get into this distinction between the objectivity of method and the objectivity of the things studied.
Yes.
And there's no question but what the method has to be objective. I mean, if I'm communicating with you, I have to do so objectively, because otherwise you couldn't understand what I was talking about.
Seems right.
I mean, I say, I feel, oh, la, la. That doesn't mean anything to you. And we have to have an agreed upon dictionary. If I say, I feel hot, that'll mean, that won't tell me what you feel when you feel hot. But by association and by learning, we come to have the same word for what we presume to be the same state. As long as you identify the color of your shirt as blue and I identify it as blue, it doesn't matter what you really feel. We needn't get into that. That's one of the reasons the non-objective, it's impossible to communicate. But you can't say it's not there, or it's not, well, there is another question. That it doesn't exist. And even that is a limitation. There isn't any other. That's the difficulty, you see, is talking about something non-objective. We both know about it, but we can't say it's there, and we can't say it exists. I like to say it is, rather than say it exists.
Yes. Language itself is designed to deal with things that are
Right.
objective.
Right. Can only deal with that.
Yes.
You can denote things, but you can't transmit them. That means that you have to have experienced that thing that I'm telling you about, and the word will denote it. But the normal objective language is not subject to that limitation, because we define things in terms of their own properties, not in terms of their relation to us.
All right.
A triangle is 3 points or 3 lines. The definition has to do only with the triangle, rather than with your relation to the triangle. There's an aspect of the triangle that's not objective, and I think it helps to bring that in at this point. How big is the triangle? Do you see that that's not objective? That's a difficult point.
Yes.
You see it?
Mm-hmm.
I'm not sure everyone would.
All right.
So you could say, well, it's 2 feet. Then you have to know you're comparing it with a foot. That requires that you know the foot. If I said it was 2 cubits, you wouldn't know. ultimately you get to something. I mean, you may compare the triangle to a foot ruler or something else. It's bigger than another thing. Ultimately, you have to define it without benefit of any prop, you see. And that is a relation to yourself. It's big if it looms large in your field of view, and it's small if it seems small to you. It's a value. The size or scale is a value, and values are always not objective.
They're subjective?
If you like.
All right.
There are other aspects that are not objective, such as what you propose to do with the triangle. What's it to you?
Mm-hmm.
That's not inherent in the triangle, you see. You might use it for a musical instrument, or you might be an insignia for a club, or it might be a geometrical device, or anything.
Right. What about the scientist's need to be objective and dispassionate related to his actual effect and involvement in the experiment?
Well, that, of course, has been very important since Heisenberg pointed out that you can't observe an electron without disturbing it.
Mm-hmm.
The older science always had this ideal mathematician, scientist, what have you,
Mm-hmm.
who could observe everything and note down its position and velocity and thereby predict what would happen. But that, he no longer, he can't do that. Any attempt to accurately measure something will disturb what he's measuring.
So how can a scientist actually ever be objective?
Well, he can be objective in that sense about what's called macro phenomena, things that are larger than electrons. He can make a reading on a dial, or any of the things that he has to do in the normal pursuit of scientific activity. He can do them objectively. I mean, if the butcher weighs the meat and puts his hand on the scale,
Mm-hmm.
he's not weighing it objectively.
Correct.
So the same criterion that the housewife would use is
Mm-hmm.
what the scientist, he couldn't push the meter reading over to favor his test. That would not be objective.
But aren't we just speaking in terms of magnitude of error? The scientist is always going to affect that meter, is he not? Because he's involved with it.
No, it's only these quantum measurements that are not objective in the sense that they're disturbed by the observation.
All right. Then that is to say that the meter itself is not disturbed at a quantum level?
It doesn't count.
It doesn't count. That's what I'm driving at. It's a matter of scale and or distortion.
You couldn't possibly detect the difference in
Yes.
reading a meter
Right.
due to the science.
So what we're saying is that it's substantially objective in accord with the purposes of observation.
Yes, yes.
All right. I wonder if there are advantages in recognizing that the universe is something other than objective.
Now you're talking.
All
I think now we're getting into the pay dirt. Science tends to begin with objects, much as Newton began with the planets and the motion of the planets around the sun, and he could invent a formula that described their motion. This was a great triumph for science, and really it put it on its way. But then, at that time, they didn't question. They talked about forces without giving it any second thought. But now they have to say, well, can we conceptualize a force? Can we define a force? But what I want to bring out is, if you say, well, force is attraction, and well, what's attraction? And you might, you would have to end up by saying, well, it's the way I feel toward my girl, or something. You have to put it in terms of some force that's acting on you. or the way I feel when I have to get up out of the chair. I have to move against the force of gravity.
Mm-hmm.
Now, you feel that force, but how do you conceptualize it? You're feeling something, but you can't put it out there.
That's true.
You can't define it. Define means to set limits to, define. You can't set limits to a force because it goes to infinity.
Mm-hmm.
So there's the problem of the scientist. How does he conceptualize a force? Now, all of science has to be written in terms of relationship statements. Such and such is between such and such and such and such, or A is bigger than B, or some kind of relationship between things. That will not do for a force. You can say one force is bigger than another, but you can't say what the force is. So this gets them to all kinds of difficulties. Among them, one way out is to say the force is due to a shower of particles. I think that's ridiculous, but I don't think we can get into such technicalities here. But I'm just pointing it out that it's what they're driven to talk about this non-objective thing, force, in objective terms. It's to say it's a shower of particles. Mm-hmm. Another one is relativity. You remember how relativity deals with force?
No, I don't.
Well, it's called bending of the space-time field. Now, presumably that's an objective description, but it's, how do you find it?
I don't.
Well, the space-time field, is that objective?
Yes.
I'd say
pardon me, I can conceptualize it.
You can conceptualize.
It's certainly not objective, right?
Right. And I think that's the only thing that justifies it. If you say, well, the bending of the space-time field is proportional to the gravity, mm-hmm. then you can conceptualize. Yes. But it shows how desperate the effort to describe the force.
Yeah.
It doesn't catch the essence of the force, which you
Yes.
know directly by your feelings.
Yes.
And so I therefore I continue to claim that the force is not objective.
All right.
And that this is drawn right from science. It isn't that science, force is part of science, and if it's not objective, then here's something that's not objective mm-hmm. within science.
I wonder if there are other elements in science that aren't objective.
Do you think light is objective or non-objective?
Wave or particle?
Well, I'm not, I'm asking you to talk about light as you know it.
It's objective in the sense that I can sense it.
You see it?
Yes. And I can quantify it as bright or
dim. Well, don't you see your dreams?
I do indeed.
Well, are they objective?
In the same sense.
You see,
through a different sense. Through a different sensory element, a different sensorially.
Sensory. Well, I'm not distinguishing between different senses. You see your dreams when you're dreaming them.
Mm-hmm. That's
are they
my
objective?
World. That's my objective world at the time.
But you forget we defined objective as something that two or more persons mm-hmm. can see. Can I see your dreams?
Oh, we did. Two or more persons have to be able to see it.
For it to be objective.
I see.
Do you agree to that?
All right. Fine.
Well,
as a definition.
Now I can go to light, you see.
Mm-hmm.
Because what we do know about light is that if you see a unit of light, which is a photon, mm-hmm. no one ever again can see that. Mm-hmm. You've annihilated that mm-hmm. photon. You've absorbed it into your system. It no longer exists as such.
Yeah.
Same way, if I see it, you can't. So that means if two people can't see it, it's not objective.
All right, so we can't both see the same photon.
Right. Now, this has led science to a pretty pass. They currently say all photons are virtual.
And what's that mean?
Virtual means non-observable.
I see.
Well, here we've made a curious trip round because we started by confining science to the observable. We end up by saying all photons are not observable. Well, I feel that you're not quite happy with this definition of objective, and a lot of people have difficulties with that, so let's see if I can make you happy.
Well, Arthur, I guess I really haven't thought it through, and I'm sort of surprised at the end product of a thought process that says that, you know, if I see a photon and you don't see the same photon, that therefore it objectively didn't exist.
Yeah, I appreciate that. But you see how it applies to your dreams?
Yes, except that I would have considered those objective in the sense that I can directly sense them, maybe.
Well, we have people coming to the Institute who talk to angels and so on, and they can't satisfy us objectively about this, so we say they're having a projective or a subjective experience.
We're saying it's hard matter that we can all experience and agree on, then.
Just because we can mutually share, transmit, communicate this experience by this objective device.
All right, I think that's fine with me.
Now, we're having this trouble right along with science, because that old nursery rhyme, the dish ran away with the spoon. The dish is the objective part. It's we can convey the food from one person to another. But the spoon is what you get it into yourself with. It's partly not objective. And if the dish runs away with the spoon, it's because we're being deprived of this non-objective participation factor that makes it possible for us to enjoy the food. So bear with me on that, but I want to make it clear to everyone. I'm making this distinction. Science made it, so I'm trying to bring this out.
All right. Okay, I guess then we were talking about light and photons and going toward their objectivity, and if they're not objective, what's the importance of that realization?
Well, that science, since it has to deal with photons are responsible for all the energy transactions in the world of science studies.
They're the basis of energy, that's everything.
Basis of the most fundamental thing in the universe.
All right. So we should consider that.
So in the cosmology, certainly the science should recognize that it's not everything is objective.
The basic element of matter then is non-objective.
Right. And the other one is forces. Forces are not objective.
But now, let's end with that basic element of matter. Once it gets big enough so that we can share in observing it, then it can become objective.
Big enough.
Like if there are a group of photons or a burst of light or whatever.
Oh yes, there are billions of
scale, as it was the meter as opposed to the electron being influenced by the observer.
Well, in this game, Heisenberg was talking about a single electron.
Okay.
So when we talk about photons, we're talking about single photons.
Yes. Okay.
They're virtual.
Yeah.
You see the light, but it's not the same light that I'm seeing.
Okay.
Now, there's another important factor to this because it reinstates in science what we call spiritual. Because the nature of the photon is such that it has no material properties whatsoever. It has no mass, no charge. It has no position. You can't detect its position except to say it's no longer there. And it has no time because clocks stop at the speed of light. So it's outside of space and time.
That's another clocks stop at the speed of light?
Oh, yes, I was taught that back in 1925 when I first took up relativity.
Uh-huh.
Well, there's the old story of the twin. One twin is kept on Earth, the other is sent through space at the speed of light and brought back after a year. He is no older than when
Yes.
he started, whereas the twin on Earth is a year older.
Uh-huh.
So either you take that on faith or you don't pay any attention to relativity. I mean, now, speaking of relativity, I can get into another
Good.
interesting demonstration of the non-objectivity. Now, relativity is actually not a theory of relativity. It's a way to find invariance. The things that are relative are position and velocity, which, because they're relative, they're unimportant.
Mm-hmm.
They are only ways to get to the invariant. The invariant is neither space, neither position nor velocity. It's acceleration.
All right.
Things like constant of gravitation is an invariant. In fact, there aren't very many. That is the major one, is the gravitation. And that's due to bending of space-time, they say.
Mm-hmm.
But remember, how did we know acceleration from the other?
Yes, we can sense it.
Sense it, but I don't like the word sense. Sensing is outside.
Feel it.
Feel it.
Okay.
We feel it.
Yes.
And feelings is what is appropriate for the non-objective, the subjective
We
thing.
can feel gravity, we can feel our girlfriend,
Yeah,
etc.
right.
All right.
There is gravity. The number one invariant, the important thing, is non-objective. I think it's the neatest turnaround because here's all this from their own stuff.
Yes.
But there's one more step, and this is perhaps the hardest. But now, because of my mic, I can't do this. But if I were to get up and turn around and sit down, maybe I'll try it. I managed.
You did.
But you see, it's not just the mic that says I can't do that. See, you'd think, according to the theory of relativity, that I could have said, well, the universe turned around me. I didn't turn around. The universe turned around me. That's relative. See, that was the...
From the point of the observer.
Right.
Yeah.
Well, what do you think? Did the universe turn around me? Have I the right to say that?
Well, I don't think you'll get anybody to agree with you.
Well, that's not
the point here.
That's not the point here.
Okay.
You have to establish my legal right to say that.
Your legal right
or
to say
non-right. Well, it's
I think
a
you
tough
should
question.
pay $200 and go to jail.
What would happen to the remote stars if they have to go all the way around? The nearest star is 7 light years away. Mm-hmm. So if it takes me, say, a second to turn around, it's got to go 6 times 7, 42 light years per second. That's much faster than the speed of light.
All right.
So the theory of relativity says that cannot be. You can't go faster than the speed of light.
I see.
So the theory of relativity itself says that my rotation was absolute, not relative.
Okay.
Now we got a pretty pass because we've got rotation as another invariant, absolute. Mm-hmm. But if I'm free to rotate, how can it be an invariant? Mm-hmm. I was stuck on that for quite a while. But it's the most beautiful thing I've ever come up with. Mm-hmm. Because the invariants, these things, we sort of speak worship because they're absolutely invariant. They can't be changed. Mm-hmm. Depend on your point of view. Mm-hmm. Your freedom of turning is your freedom of choice. Mm-hmm. And once you've made a choice, you've established a set of invariants.
Mm-hmm. Which are non-objective.
Right. But they are the criteria by which you will act. They're the important things. Mm-hmm. But it's your choice that makes them important. It's not that they're important fundamentally. I mean, they are fundamental, but this is even more fundamental, that your choice changes. Suppose you had to go to jail. Now, that's terrible, isn't it?
Probably.
But you could change your point of view and say, well, I'm going to study jail life.
Mm-hmm.
And the whole thing would, instead of being a negative value, would be a positive value. I'm bringing in once more this point about freedom being the ultimate and most important point, even if you stick to the physics book. Right, so out of the maws of physics, I'm plucking the pearl of freedom.
Yes. All right.
Well, I don't know, are there any more questions?
Um,
Well, see, we've covered quite a lot of ground. We began with is the universe objective? Is the world objective?
Right.
And I've tried to show that physics has to recognize these non-objective factors. And I ended up with what I think is the most important thing of all, your freedom to turn, your freedom to choose different goals, as transcending even that formidable array of invariants set up by relativity.
such as rotation and gravity.
Such as gravity. They don't like to talk about rotation.
Oh, I see. All right, that was your addition.
I can't find, several of them have touched on rotation, but dropped it without knowing what to do with it.
All right. Well, thank you. That satisfies me quite thoroughly, and I appreciate speaking with you.